Hi everybody, my name is Joe Brooks. I'm a solution specialist at MLC CAD Systems, and today I want to show you a couple ways that we can save some time, and we're not even going to have to involve a DeLorean or a flux capacitor, and we won't even need 1.21 gigawatts. What we've got here is we've got a pretty simple little part that I've set up here like we would use it if it were on a 3-axis vertical. Over here in my operations manager, you're going to see I have op1, op2. Down here along the bottom, you're also going to see I have this organized into 2 different ops. Now, the reason that I have it set up like this is because what I have is all of my tool pathing and all of the programming has been done on this part without wireframe, and it's only been done in one part in the single orientation. So let's take a look down here first. With my bookmark set on op1, I have everything visible for my op1. Now, when I click on the op2 bookmark, what you're going to see is the visual orientation of the part has actually changed. It shows a secondary piece of fixturing, and all of these things are available for our op2. Let's go back on over to op1 because that's where I actually want to concentrate this morning. So if I rotate this part around, the first thing that I want to look at is what I've got up here as far as my high-speed dynamic OptiRough toolpath. Now I've got my advanced toolpath display on so you can see the endpoints of the arcs as well as the endpoints of the lines, and you can see that I have that toolpath filter turned on. All right. Now, if you guys are like me in a lot of situations, what you'll end up doing is when you get the first run of a part, you'll end up wanting to do a prototype, which we'll do on a vertical, which I have done here. But then what happens when that actually goes to production? Well, you don't usually run production of any kind of high quantity in a single station where you're flipping the part over. It's not very efficient. So let's look at a way that we can take this program that we've already created and transfer it over to a horizontal without reprogramming it. So in order to make that happen, what we're going to do is we're going to do a few things. The first thing we're going to do is come up here to the very top. On mine is located in about the middle, and yours it might be over off to the right-hand side, but what I'm looking for is the machine tab. I'm going to go over here to my mill, and I'm going to drop this down, and I'm going to add in my 4-axis horizontal. All right. Once that machine is loaded, the next thing that I'm going to want to do is I'm going to want to bring in some fixturing or some other tooling that I can put this on. So if I look at my level manager here, what I have right now is I have my fixturing, I also have the solid, I have stock, and I have the fixturing for op2. So let's go back up here to the top. I'm going to go under File. I'm going to go down here to Merge. And what I'm going to merge in is my Tombstone fixture, which is a parasolid file. So I'll go ahead and click Open. It's going to bring that in an orientation that would be normal to the top view or whatever orientation it was saved in previously. I'll go ahead and accept the scale and rotational factors there because I'm going to position this dynamically. Now, before I can position this dynamically, what I really need is I need this to be on a single level that's going to make it much easier for me to select. So I'm going to go ahead and create a new level by typing it in down here. I will select level 500. I will label this level HMC. We'll call that HMC tooling. All right. Now I want to move all of these entities to that level. Well, one of the easiest ways for me to do that is actually rotate here to the front view and drag a window around everything. Select that whole fixture right there. Once I have that whole fixture selected, I will simply right-click. I'll go up here to my levels, and I will select Change Levels, and I will move those entities to that level. Now over here we can see that 14 entities have been moved to my HMC tooling level. Now I don't want all of these extra levels in here, so what I'm going to do a little cleanup is I'm going to right-click over here. I'm going to come down here to where it says Purge Empty Levels, and I'm going to say Purge All Empty Levels. That's going to give me my original levels with the addition of my HMC level right there. All right, so to make positioning this part upon the this tooling upon the stock and fixture a little bit easier, what I'm going to do is actually turn off the visibility of the fixturing and the part, and I will turn on the visibility of the stock. And I can see the stock there, and if I want this to look a little clearer, I can turn off my toolpath display by using Alt plus T. That will turn off my toolpath display for me so that I don't have to look at the toolpath on the screen itself. All right, so that being said, now let's go ahead and position this fixturing onto the part. So what I'm going to do is I'm going to go ahead and drag the window around all of that. Now you notice it selected the fixturing as well as the part. I can simply click on the part to deselect that. Once that pre-selection is done, I'm going to come up here to my Transform tab. I'm going to select Dynamic Transform. And it's going to give me a gnomon here that I can use to position the part. Well, what I want to do is I want to actually rotate this around so I can look at the lower lip of this cutout here on those jaws, and I'm going to select the midpoint of that. All right, doing that would allow me to move it in any single axis by clicking on these lines here, but I can also click on the gray sphere right there in the middle and drag the entire part and reposition it. So I'm going to zoom in down here, and I'm going to click the midpoint that is the lower edge of my stock, right there. All right. After I have it positioned like that, I will grab around here to rotate around my x-axis, and I will rotate that negative 90 degrees. All right. So doing that, we have the positioning done of our fixturing around our stock. All right, that's pretty fantastic. Now, I don't like to have this as the result color, so I like to clear those colors, which I'll do like that. Now, the next thing that we need to do is if we look at under our planes, you're going to see that I have an op1 and an op2. But in order to make this work, because most horizontals are programmed around center of rotation, we need a work coordinate system that's going to represent that. So what we're going to do in order to make that happen is we're going to come down here, we're going to drag grab our gnomon. This will put us into the new plane creation dialog. And we can just snap it to the bottom here. But as you can see, it's snapping to that face, and it's not really giving me a center point. So what I'm going to do is I'm going to select the midpoint of the edge of this face. And I'll select its opposite midpoint over there. Now doing that is going to highlight this point in the center that I can use to select. Okay, so that's there, and that looks pretty good, except Z is facing the wrong way. I actually want my Z axis to face up through the middle of the tombstone, which I can do that simply by rotating negative 90 degrees around that X axis. Once I have that done, I'll give this a unique name. I'm actually going to call this HMC WCF for my horizontal coordinate system. And then I will accept that. All right. So now I have my fixturing positioned on my part. I have a coordinate system that represents what we can actually use within our machine tool. So let's go back over here to our toolpaths page. And what we have now is we have our machine, we have our toolpaths up here. So to make this a bit easier for myself, what I'm going to do is I'm actually going to grab this first operation right here, all of these toolpaths included. I'm going to right click and hold down my right click mouse button, and I'm going to drag these down here and then release above this group. And I will tell it that I want to copy those toolpaths after. Now it's going to give me a warning here about operation compatibility. That is a coolant difference between the machine that I have loaded and the machine that I'm using for my vertical. It's going to tell me that a similar tool already exists. I'm going to say yes, I will accept those similar tools and move on. Now I have those operations down here under my horizontal. All right, but that's not all. Because one of the issues when we move a part from a horizontal to a vertical, especially if we are programming from center of rotation, is that this part now exists in positive Z space in relation to center of rotation. So how can we fix that? Well, I'm going to fix it a couple different ways. What I'm going to do here is I'm going to right click on this entire group, and I'm going to say edit selected toolpaths, edit common parameters. And I'm going to do two things in here. The first thing I'm going to do is fix that coolant compatibility, and I will change this coolant to be on as well as with. And I'll click my green check mark there. The next thing I'm going to do is I'm going to address my plane issue. And what I'm going to do is I'm going to tell it that I'm using my HMC WCS for my coordinate system, but I'm going to leave my tool plane and construction plane there for op1. Now, this will generate G-code in relation to the corner point of this part. If you need it to generate G-code in relation to the corner point or to the center point of rotation, we can go ahead and leave those set as horizontal WCS for now, and we will need to create an alternate plane that is rotated to represent that. So let me actually show you both ways. So if we were to leave this set with our op1, like so, we can green check mark that, regenerate these, and we would be able to post these out with center of rotation being the center of our tombstone here. However, our point that we're referencing would still be this origin point up here. So what if we really are programming off of center of rotation? Well, if we really are programming off center of rotation, it only takes one other small change. What we're going to do here is we're going to go into our planes. Instead of creating a whole new plane, what we're going to do is we're going to right-click on this HMC WCS, and what we're going to do is something called Create Relative To. And what we're going to do is we're going to create a front plane relative to the WCS that we created, but I'm not going to call it front. What I'm actually going to call it is B0. I'll click my green check mark. Now I have my B0. If I want to get this B0 to have a very specific work coordinate output, I can change this to manual. And I can change this to, let's say, 3, which would be your G57 normally. Now all we need to do to use that is we can go back here into our toolpaths. We can click on the entire group again. We can right click. We can say edit selected operations, edit common parameters. Now this time when we go in here, we will select planes again. And we're going to go ahead and change this tool plane to this HMC WCS B0. Okay. And we can green check mark that. Now, we're going to go ahead and accept this because there's a couple things that I want to show you that's going to happen here. And as soon as that is done processing, we can look at this. So if we look at our toolpath display, I'll turn that back on again by hitting Alt and T. Or alternately, you can come back up here and say toggle display of selected operations and turn that on. Now, when we look at this, we see a couple issues. Some of those toolpaths are now projected down. Now, in order to see that a little bit better, let's look at this a little bit. So what I'm going to do is I'm going to go into my levels and I'm going to turn off my HMC tooling. And I'm also going to go ahead and turn my part on and my stock off. Now you see that those toolpaths are now way down here at what would be the origin point. Now let's look at why. If I look at my surface high-speed dynamic OptiRealth, what I'm going to see here is in my Z depth, under my depth limits, I have select use depth limits on. Well, what I need to do is I can either turn that off or I can modify those depth limits to work in accordance with my new plane. Let's go ahead and turn that off. We will reprocess that. And we can see that now these toolpaths are all in existence approximately where they should be. All right, well, that's great, right? Let's turn our fixturing back on so we can see that. So what about putting it on the other sides of the tombstone? Well, we can actually do that fairly easily. What I'm going to do is drag my little line indicator here down to the bottom. I'm going to right click over here in my operations manager and come up to mill toolpaths. I'll come down and select transform. What I want to do is I actually want to do a type of rotate. My method will be tool plane. the source will be the NCI, and the order will be operation order. Now over here, the group that I'm going to select will be this operation group for our horizontal machining center. I'll come up here to rotate. The plane that I want to rotate about is actually going to be that HMC WCS that we selected. Now, once we select that plane, we must also come over here, because that plane's origin point and MASTERCAM origin do not align. We need to come over here and actually select the rotational point, which we're going to do by selecting the origin of the HMC WCS right there. Now, how many times? Well, we're going to do this 3 times, starting at 90 degrees with 90 degrees between each increment. All right, we'll go ahead and accept that. Now, as we can see, we have parts on all 3 sides of that. Plus our original group would give us the 4th. Now, what if we need to change clearance for rotation? Well, changing clearance for rotation is fairly easy. We will come up here to Mill Toolpaths, or to our Edit Selected Operations, Edit Common Parameters, and we'll go in here and we will add in a clearance of about 6 inches. We will enable that clearance. When will we use that clearance? We will use it at the start and end of each operation, and we will use that in an absolute mode. We'll select that. We'll go ahead and regenerate those operations, and we'll see those come in here with that clearance enabled. All right. Now, let's look at a couple other things that we can do to save some time when we're talking about our programming time here. Now, when we look at this surface high-speed dynamic, for instance, and we come down here and we look at our arc filters, we can see that I have an arc filter of 5 thousandths, and I have it set to create arcs in the XY plane. Now, what would happen if we didn't use our arc filter? Well, let's take a look at that real quick. And I can do that by turning that off. I'm still going to use the same tolerance. So the accuracy of the toolpath does not change. However, we can see that toolpath that was at approximately 757K is now at 4,817K. And we can see that with my advanced toolpath display, all of these little green dots that you see here represent endpoints of lines. So we can see all of those long line segments that I had and those arcs that I had have now been converted into these tiny little segments. If you ever want to see that just a little bit better, you can always go up here under your Home tab and use something called the Analyze Toolpath. That's going to allow you to come out here and click on these, and it's going to tell you what they are at any given position. These are all positions. You have one small little arc right there. You can see that by the G2. You can also see that I didn't have coolant on there. That's something that I would want to go and fix. Okay. So now let's look at what happens if we just turn that back on. Again, with the same tolerance, same total tolerance of 5 thousandths. I'm going to drag that slider over there, telling it that I would prefer that tolerance to be used to create arcs. Reprocess that toolpath. And we can see now what we have is where all those little line segments were. We now have much longer, much smoother arcs and lines. So let's take a look at those now. Now we can see that these are still, they're lines, but they're nice long lines instead. And we have a nice arc here. We even have arcs here and here. You can also see that, again, the coolant is not turned on. Well, that's actually a pretty good point to make, because that's something that I used to forget to turn on all the time, as again, I've obviously done here. So what do you do for that? I mean, we could go through these and we could select them one at a time and come down here to coolant and turn it on and everything's fine and dandy. But what if we don't want to make those changes one at a time, one at a time, one at a time? What are we going to do with that? Well, we can do our group editing, right? We can select the group. We can right click. We can edit selected operations. But what about this? we can also come in here and look at our files, and we can look at our operation libraries and our operational defaults. We can actually edit these operational defaults. And we can come in here and we can find any particular operation or even a whole group of operations. We can take every single operation that exists within our operation library. We can right click, we can edit selected operations, edit common parameters, and go into coolant and have it default to on. Now we don't have to remember to turn on coolant anymore. What about the toolpath filtering? Well, that's something else that we can also adjust in these operations. So as we go down here and we look at some of these, right here, surface high speed dynamic OptiRough. Well, we can expand this. We can look in the parameters of this, and we can look in our arc filter tolerance, and we can say, okay, we want it to be 5,000, so we want it to default to arcs with those settings on. You can do that for all of your operations here. You can come down here to your finished parallel toolpath. And if you have settings that you know work consistently for your surface finished parallel, then you put those arc filter settings in here. You're like, all right, Joe, well, that's great. What if I don't have them the same for everything? What if sometimes I use different settings for stainless than I do for aluminum? Then you save a separate library. You'll have one library up here for your aluminum, one for your stainless steel, or you can separate those libraries by machine tool if that's what works out best for you. But you'd be surprised how much time you'll save just by eliminating a few of those button clicks. There's one other way that you can edit those operational defaults as you're going through there. If you don't want to go through and adjust those as a group, from within the parameters of your operation, you always have this button right up here, which is Save Parameters to the Defaults file. So when you find something that works, you can click the Save Parameters Defaults file. Those parameters will be saved, and then you'll be able to use those next time you start a new file and start going through that. So those are just a few ways that you can save time when you're going from machine to machine, as well as save time with the actual programming method. And none of those things will require a flux capacitor. They won't even require Dr. Brown or even a DeLorean. Although if you want to get a DeLorean for fun, that's probably a great idea. All right, everybody. I hope you have enjoyed this and have a great day.